integration by parts, like we're saying, there's just the antiderivative of the product rule. Okay, it is derived directly from that. I'm not going to show that to you. I don't think it's necessary, but that's where it comes from. Okay, so basically what we have is some people will call this the integral product rule. Okay. So we're going to be solving problems that look like this. It's very tempting to say I might be able to substitute that problem, right? But we can't because the derivative of x doesn't come out here. Okay, so it's very similar looking to a lot of substitution problems, but it's not. Okay, so basically, you're going to use derivatives again to solve an integral. Okay, so we're going to set, it's just a formula. Okay, we're going to set this is how I remember it. The integral of u and dv. Okay, so in our case, this would be a derivative. Right? Or some people write this v prime of x dx. Right, so we have that which we choose and that which we choose. Okay, so u equals x in this case, and do you prefer v prime notation or dv? Okay.
What is it going to look like on the
Um, this. You got to come up with all this.
Okay.
Yeah, so this is what it looks like. So v prime is cosine x. Okay, so you got to choose those two, and obviously there's only two choices, one or the other, right? If you get it wrong, you can switch them and try again. Okay. We need to derive that.
Wait, so it matters which one you choose?
It does matter. Okay, because if you choose these incorrectly, it's going to just create a circular integral that never works out. But if you choose them correctly, and this is the right technique, obviously, you're going to get a solution.
So how did you figure out which one to choose here?
We'll get to that.
Okay.
Yeah, there's a little, there's a word that you can use to kind of guide you. It's not definite perfect, but it can kind of guide you. All right, so derive this, right? Now that's good because integrating one is easy, right? And then anti-differentiate to get v. Okay, what's the the integral of cosine? Sine? Right? Okay, you've set your problem up already. So, here's the formula. So you've got your setup here. UV, so ultraviolet, that's where I said ultraviolet super voodoo, right? So ultraviolet minus super voodoo. Okay, obviously this is going to be U prime. Okay. And that you just plug those in.
So does U usually come out to be a number? Or U prime maybe?
No, but if you do it right, it'll come out to be something that works with the V. So, all right, so plug your stuff in here. We've got x is u and v is sine x, right? Minus, and then what's v? Sine x again? And then du is right here, is 1. Dx. That's doable, right? So you've taken this nastiness and made it a problem that's doable. So we'll get x sine x. What's the integral of sine? Negative cosine, right? There you go. That's your answer. And if we derive that, here's our product rule, right? It'll come back here. Cool. So again, choosing wisely is the key on this. Let's look at another one. Are you good with that? Okay, so here's the formula. Integral of u v prime equals uv minus integral of v u prime. Again, to memorize.
The product rule is just like.
Yeah, so you got a product here. So
What
ultraviolet minus super voodoo. What?
That's what I was wondering. What do you think?
I couldn't hear you, sorry.
I was just wondering what the saying was.
Yeah, so ultraviolet minus super voodoo. Okay. There is some wisdom in choosing which values that go with these. Okay. It is this right here. You remember that word. Make sure I got all mine straight up. Exactly, right? Okay, it's a, what does, this is how we choose U. So U is, okay, this is, it's kind of a general guide, it's not perfect, but L is logs. So if you see a log, most likely that's number 1, you're going to choose that for U. Okay, so log. And then inverse trig. Okay. What could A be? Holy cow. It's just, where is it in my brain? Logs, inverse trigs. I'm going to have to go look.
Algebraic.
It's algebraic.
That's it, third one there.
I think that's right. Yeah. Algebraic, trig, and then exponential. Okay.
Well, wasn't
So-
there algebraic and trigonometrical?
Yeah, that last one has an algebraic function and a trig function, right? Which one's higher up the list, though? Algebraic.
So it's just like that.
So choose algebraic first.
So it's just like that.
Yeah, it's an order, so going top down. Okay. All three of these, notice they get more simple when you derive them. That's why we choose it as U, so when you derive it, it becomes more simple. These do not. Right? Trig function is just cycle, right? Sine, cosine, negative sine, etc. And exponential is the same. 2 to the x is natural log 2, 2 to the x. 2 natural log 2 to the x's. So these cycle, but these get more simple. That's why they're at the top of the list. Okay. Let's look at So looking at the list, which one would you choose for u? Yeah, because it's algebraic, whereas e to the x is exponential, right? So yeah, we're going to choose x as u. And v prime is e to the x.
Why, is there a reason you decided to be prime rather than b?
Yes, that's how the formula works.
Okay.
So if you derive it, again, directly, if you get the product rule and you write it out for derivatives, take the answer and integrate. Yeah, that's directly where this comes from, and it requires that this is the derivative. Okay, so u prime is 1 and v is e to the x. Thank you. All right, so we have, again, always writing down the formula just so we get it memorized. So uv minus integral of v and du is 1 again, thankfully. Right? You okay with that one? Do you want me to show you what happens if you choose the opposites? Okay. So if I choose u as e to the x and v prime as x. Okay, see, that does not get more simple. V prime is an integral. See how everything got more complex or stayed the same? It's a good indicator that you're hosed, right? So if I write my formula out, u v minus the integral of v du. And can we do that integral? No. So we can't even use substitute that one or anything. So unwise.
So it'd be pretty obvious.
Yeah, there are times when this has to be done twice.
Okay.
I'll show you one, but it should be pretty obvious. You can't do this. It's just, it's getting more complex. That's the problem, right? So you don't want that. That's the big clue. Okay. All right, let's look at this. What's my u value?
X squared.
Yeah, good choice. And v prime is cosine x. So what's u prime? 2x. And v is sine again, right? And again, write the formula out. Remember that when I write du, it's just saying u prime, right? Keep that in mind. So x squared sine x minus sine x times 2x. Okay, can I do that directly? No, so I have to do integration by parts again.
Nice.
Yeah, nice. You think it's nice. You're becoming a calculus nerd. What's my u value going to be here? Yeah, so if you pick 2x, the derivative is 2, right? And now we're getting more simple. V prime is sine x. That means V is negative cosine. Right? So don't forget, if you have to do this twice, the minus sign is going to carry. So make your brackets there. That should be an x. uv minus integral of the, right?
Oh, okay, so that's,
So there's another UV minus ultraviolet minus super voodoo.
so that's
It's a
the,
second one.
so that's the integral of sine x times 2x.
Yeah.
Okay.
So this whole thing right here is this right here. Yeah. So this carried, right? Yeah. So let's finish it up. That's going to be plus. What's the integral of cosine?
What would be the sine cosine?
Oh, negative cosine.
Um,
Negative sign. So we have minus, minus, minus. That's a negative 2 sine x out the back end. Right? There you go. That's twice. If you need it.
Will we ever have to do it more than twice, do you think?
I doubt it.
Maybe like for one question. If that, it's only gonna be like 8
The
problems.
problem with doing that is the time component. If they're gonna test you in a timely manner on many different subtopics in calculus, they can't make these really difficult.
Right.
'Cause even a double, I would be surprised for it to show up. Because what we're testing is, do you know integration by parts? You can do that and show it in a one-stepper. You don't need a double. So, considering the breadth of BC, I doubt a double will show up on a test, but just in case. All right, let's show you one more, and we'll be done. Have you ever integrated natural log x?
I thought it was 1 over x.
No, that's the derivative. Remember?
No, we have not.
Yeah. So this is an integration by parts problem. Is that natural log x going to be u or v? That's the question. The u or v prime.
What would it be? There's only one thing.
It would be
Yeah. What's the other function here?
1.
1. Yeah. Okay.
It'd be u because logarithm. Natural
Which
log.
one's here? Here, natural log.
Which one?
Yeah, it has to be, right? Because we don't know the antiderivative of natural log x. So u prime is 1 over x, and v is x, right?
So it was like v prime, I guess.
1.
No, but you put v prime again.
I just wrote v. I think I said u, didn't I?
Yeah, you did.
Thanks for the catch. Okay, and then set it up. Guess that is a problem with my handwriting. I curved my v's a little bit. X natural log x, that's uv minus the integral of x times 1. All right, see how much easier that becomes?
Oh, it's x times 1 over x.
Oh, it is.
So then that's just 1.
Yeah.
So just the integral of 1.
which you've derived that many times, I think. It's one of the mainstay problems in natural log and product rule sections. So, there you go.
So, but because you have
Oh,
numbers in the
gosh
top.
dang it. Yeah, I got in like mode. Let's not do a plus C this time. And let's evaluate from 1 to 3. Yeah. And 3 ln 3 minus 3.
So the only difference is that you're doing a different way to get to that same.
Yeah, it's the same thing as a definite integral. What's natural log of 1? 0. Yep. So you got a 0 there. All right.
So what's 40 times natural log of 3 minus 3?
So you have -3 and then minus -1, so it'd be -2. Right? Which could also be, you want to do your logarithm rules, remember? This could also be written as natural log 3 cubed minus 2. So that could be natural log 27. This is the many iterations of a possible multiple choice answer. So be careful on those. All right, questions? Let 'em out. Well, there's your homework at 7.1. Do you want to do tomorrow or Tuesday? Because I'll give you, tomorrow, we'll start improper integrals, but I'll give you until Wednesday, because we'll do it Tuesday as well.